We make a Venn diagram for example number 4, study of 100 student children. So we can make a box, and that box is going to represent all students, right? And then we can talk about those two sets. So this is one of the set, and then we have another set right there, right? And we see that there's an intersection. Most of the questions are going to be like that. So universal set and A, that is B, and that is the intersection of A and B. Now, the whole universal number in the universal is 100. 100 students in total. It's revealed that 22 of them either did not eat breakfast. Now I call the student breakfast, having breakfast is set A. Either did not eat breakfast or did not brush their teeth. And brush, I call it B. The set of students who were brushing their teeth, they're right there, and we're having breakfast are in A set, right? Now they're saying 22 of them either did not. No, when they're saying did not eat breakfast, that means A complement. A complement that a student is not in the breakfast set. Either that or that means union by did not brush their teeth, that means B complement, right? So one of that case, they're 22. Now let me call X, Y, Z the values as they are naming them. The students in the A, only A, that means the students who are only having breakfast but not, they didn't brush their teeth. That's that part. I'm gonna use green for that. These guys are only cleaning their teeth but not having breakfast. Let me call it as they also drew that here. Z. So I'm gonna use the same symbol so that's easier for you to go over that. And these are good students. They're having both of them. And so Y variable. Now, either did not eat breakfast, that means the complement of the A, everything outside of A and everything out there, that's the complement of A, and the complement of B is gonna be everything out there. So basically they're talking about the union of that. So their union, you're talking about the union which is right there. This region is 22. So x plus 1, z plus 1 is 22. X plus z plus 1, right? Now when we say A complement is containing z, right? And B complement is containing x. So does it make sense to you? So when we say union, that means the green part. So the only part which is not included is that red part. So this is everything outside of that red part. The combination of A complement, B complement is everything excludes that, which is 22. Now the next statement, if 88 of the school children brushed their teeth before school, now 88 brushed their teeth, and that is B. So n, I use black. N of b, that means the number in b is 88. If 88 of the school children brushed their teeth before school, that means n, b, the whole thing, y and z together. B is made of y students in red and the green zone, so this implies that y plus z equals to 88, right? And now the next statement, the final statement probably. And if every child except one, now they're saying except one, there's a one guy either brushed their teeth or ate breakfast. Everybody did that thing, but there's a one student who didn't do anything. One student, even he didn't have breakfast and didn't clean the teeth. And this guy is sitting out there. So we have students in those sets, and one student is a bad guy there. Now that's everything. Now the question is, how many children ate breakfast? So the probability, sorry, not probability, the number in A, that is the question. That is the question. So I break down the entire statement in these three equations. Right? Does it look good to you? Now let's solve it here. It's just a couple steps. So the main thing is understanding the statement. So you go slow, read one statement, write mathematical equation, and then the question is that. So in order to answer this question, you have to know A. Now what is this A? A is made of basically X and Y. So what we're gonna do, so that means basically the question is, what is X plus Y? Make sense to you? Number in A are these blue guys X in total, the red guys are Y. So we have to find X and Y. Now the equations that we have are, this is one of the equation in Y, Z. But we didn't write the equation for this thing. So let's write the equation for that. This is representing the area where we don't have the red. Representing everything except red. Right? We already have gone through that. So A complement means everything outside A.
So it's 34. The answer is 34.
Yeah, let's do that. Everything outside A complement is Z. And B complement is everything outside B, which is that X. And there's one guy which is also the part of B complement, A complement, and that is just one guy. So Z guy, X guys, and this one guy right there equals to 22. So we got two equations now. And what else? We have this statement, that one. The YZ is 88, 99. Yeah, now the final statement that we didn't write yet. All those guys together, they are 100. We didn't use that thing yet, right? So let's use that. Now when we say that universal set, the universal set is made of all those people. One guy, Z, Y, and X. Total should be 100. So let me write down the statement, probably right here. All together, they are making 100.
So it's 33.
Pardon?
It's 33 because there's one guy outside and there's 88 in B plus Y. Z plus Y.
Yeah, now we're gonna solve that.
Yeah.
So we have 1, 2, 3 statements, 3 variables. That means we can solve them. And now we let's do it here. So yz is 88. So we substitute yz here and find x. Would be that?
Hmm?
Will be 11, right? Let me
Yeah,
do
if, yeah,
step
if
by
you
step.
add the one guy on the outside.
Yeah, let's do it step by step. So we substitute it here, and we're gonna get x plus 88 plus 1. So x equals 200 minus 89, which is 11. So we have now x. We have to find y. So in order to find y, you substitute 11 in one of the equation here, and then we go back and find the y. So let's find z now, because y, in order to find y, you have to know y and z, x and z, sorry.
Mm.
So now we put it in that equation, and by substituting there, we got, nope, not in there. We substitute it there in this equation. X plus y is that, or we can simply substitute x plus z in here. Now we have x plus z plus y plus 1 equals 200, right? X plus z plus y. So I rearranged them because I want to substitute zx and 1. Zx plus 1 is 22. So we substitute that, which is 22. So y is 100 minus 22, which is 78. Now, my y value, does it make sense to you?
Mm.
Y, sorry, z, x, and 1, z, x, and 1 are 22. So you replace them by 22 and then find y. Now the question was, what is x plus y? Well, what is NA? NA is made of x and y, x and y. So the sum of them is your answer. So we substitute, therefore, is 88, right? 11 plus 78, sorry, 78, not 89. So that is the answer. So therefore the students, children are having breakfast. Children ate breakfast are 89. So that is one of the hard kind of question in this section.
Okay.
Any
No, that
question?
makes a lot of sense.
Yeah. So I found this one like one of the most hard question, but
Really?
yeah, because there are a lot of equations, right? If you forget one of the equations, then it's hard to establish a relation, and
Yeah.
then it's hard to evaluate the x and y. So
Exactly.
there's a lot of algebra, and on the same time, the understanding of set theory.
Okay.
Yeah. Right. So we can pause. Actually, this is a nice option there. Now the next problem, example number 1, page number 9. I will write page 9. Example number 1. So we are doing tree diagram. So in order to understand tree, we have to go over that. Jennifer and Kristen are playing tennis. They agree to play a best of 3 series of games, best of 3, in which the first person to win 2 games is the winner. Whoever wins the first 2. Now, this is the first game that's happening right there, this dot. and this game can result in victory of Jennifer or the victory of the Christian, right?
Mm-hmm.
And now there's gonna happen the second game. If J is the winner, then the next game is gonna be determine who is gonna be the winner, right? Now, if J is again Jennifer is winning that game, then Jennifer is the winner according to the game setup. If K wins, then now we have a kind of tie. Jennifer win and then K win. Now we will continue the game. The third game is gonna happen because both have one victory in this row, in this branch. Now, if Jay is winning that, then the winner of the game is Jennifer. And if Kay is winning that, then Christian is the winner. Because according to the setup, whenever you the first two games, whoever win first two is the winner of that series.
Yeah, so they each have
So
a 3 out of 6
yeah,
chance.
so this branch is exhausted according to the question, and now the Kristen, if she's the winner in the same context, it's the second game, which is happening right there. That's the first. Second is right here. Can result in the victory of J or K. Now, if J is the winner, the game is gonna happen. If this happens, then Kristen is the winner of the game. Now we have further two branches, J, K. Now, if J is the winner, we stop there. Jennifer is the winner, and otherwise Kristen, because K, J, K. So um, these are the results. Now they may ask you the probability. Now you understand the branch, right?
Mm-hmm.
Whoever wins first two games is the winner. Now the probability, they may ask you what is the probability that Jennifer is um, the winner of this game, of this series. So we see that she's winning right there, J, J. And here she's winning again. One, two J's, right? And one K. And in this one we have two K's, no, only one J. So Kristen is as the winner in this branch. And why that branch? We again have two J's. Let me write it down. K K J. And this is gonna be K J K. So Jennifer is not winner, and here Kristen is the winner. So Jennifer is winner in this case, that one. So three cases are there. So we have three options out of one, two, three, four, five, six. So six are total outcomes,
Mm-hmm.
and out of these six, two are in the favor of Jennifer. Three, sorry. So three out of six is 1/2. So there are 50% chances that Jennifer is the winner of the series,
Mm-hmm.
and in the same context, the K will be also 1/2. But now the question is, they may ask you, what is the probability that Jennifer wins at least one game? J wins at least one game. What you gonna do in this case? So we have J. There's only one case when we don't have J, right? In this case, Kristen is winning both of the games. So um, this is the case that we are looking for when J and we can do like 1 minus 1/7, 1/6, sorry, or the question is wins at least one. So at least one means one, two, three, four, 5 cases. Because in all these 5 cases, we see the J at least one. So you can do it right away, like 5/6.
Okay.
Or you can do 1 minus probability that J wins 0 time, which is uh, 1 out of 1 out of 6, right?
Mhm.
So we do 1 over 6,
Mhm.
and it's gonna be the same thing, 5 out of 6. Good.
Yep.
Alright, so that is that. And yeah, many other questions like what is the probability that Jennifer um, wins too many times?
Mhm.
Exactly too many times. Then you're gonna write 1, and that's 1 as well. So 2 out of 6, which is 1/3.
Okay.
So what is the probability that Jennifer wins 2 games in a row? Right, that is that. Or in a row, actually, not that one, this one and that one. Yeah, that's right, in a row. So the probability that Jennifer wins in a row is these 2 cases. So
Mhm.
2 out of 6, which is 1/3.
Okay.
I think it's understood, right?
Yep.
All right. So we right. So S is made of A, B, C,
Mhm.
and we are interested in subsets of the A subsets. Now let's write down subset explicitly. Now, um, one is A, B, C. So single numbers, right? And then we can have A, B, B, C, and A, C. So we always separate them by commas. And the final one is A, B, C itself. So that's the power set of S. Sometimes they call it power set, but you don't have to call it anything. So how many subsets are possible there? 1, 2, 3, 4, 5, 6, 7. Right? There are 7. So power set is made of 7
Yeah.
in this case.
For a
Any
proper set.
other? Yeah. For proper subsets, it's gonna be 1, 2, 3, 4, 5, 6.
Yeah.
6. So let me go over the textbooks. So I missed something there, which is empty set.
Oh yeah. You were supposed to put it at the start, right?
That's 8 in total. Pardon?
Oh, you're supposed to put empty set at the start.
Yeah, you can write it anywhere. 5 means a set which is not containing none of them.
Okay.
So in total, we always include that as a subset. So 8. Now we have a shortcut for doing that. So the shortcut is you write the n, and there's 3 elements in this, and number of elements in power sets are gonna be 2 raised by 3,
Mhm.
which is 8. So always you do that. For example, if number of elements in S is let's say 5, then the number of possible subsets is gonna be 2 raised by 5. These many subsets we can make. Like for example, let me write S is A, B, C, D, E, uh, and number of possible subsets which are gonna look like that, and they're gonna be more than that obviously because we have more elements in S,
Mhm.
and these subsets that we're gonna build up, they will be these many in total.
Okay.
So you're gonna do 2 times 2 times 2, which is 32. So you multiply 2 5 many times. So 32 subsets are possible. So that is fundamental counting principle.
Okay.
Now the next thing is related to the fundamental counting principle. For example, if you have a set, actually we have to open new slide there. Um, let's say we have and all um, unit place digits 1, 2, 3, 4, 9. Now, if you want to make a lock, let me turn this thing off. Now let's assume you want to make a lock, and that lock is having four, digits on it. How many codes you can create that for that lock? That's the question. Now, the first position. Let's start from the left side. So we have 9 options for that. We can pick any one of them. So we can place it on this position. So we have 9 ways for that. Now, and the second position. Now, the repetition is allowed in these kind of cases. So you can write the same digit. For example, if you write 3, you can write 3, 4, 4. So it's completely independent of that one. So it doesn't depend on that. So still we have 9 ways for that. 9 ways for this one, and so on, right? Now there's a sense of and. The first spot, and second, and third. So we have 9, 9, 9, and there's a sense of and. The first spot, and the second, and the third, and the fourth, right?
Yeah.
Whenever there's a sense of and, we multiply. If you have a sense of or, we add them up. Now we're gonna multiply them. So 9 raised by 4. Good.
Okay.
Now let's do the same question without repetition. Now,
You'd have to do 9, 8, 7.
now you got it. So the first spot, we can fill any number 1, 2, 3 up to 9. 9 ways. One of the numbers filled. Now we left with 8 digits. 8 ways, and 7 and 6. Every time we are filling one, right?
And if they say like in the question like no repetition,
Yep.
But it can't be over the number 2,800.
Yeah, we're gonna do that.
Oh wow. That
So
makes so much more sense.
yeah, no repetition. That means every next will have one less option. If you fill, let's say, 7 there, now we cannot fill 7 in the second spot.
Yeah, but you
So
could put
8
9 or
ways,
something.
yeah. So then we have one less, and total number of ways are gonna be 9 multiplied by 8 times by 7 times by 6. Those are total ways or total codes that we can create for making a lock.
Okay.
Now, if they restrict to a smaller set, let's assume the sets are 0, 1, 2. In that one, I didn't include a 0, right?
No.
Now let's say I 4, 5. I have only these many. 1, 2. I missed 3 actually. Let me write down. 4, 3, 5. 0 to 5. Now, if they ask you to make 3 digits code, repetition is not allowed. Now, this is important. Or let's say we're not making a lock this time, but we have to make how many 3 digits. How many 3 digits number we can make using elements from this set, using digits from this set. Now we have to make 3 digits. Now 3 digits looks like 324, for example, and this is 2 digits, right? 29 is 2 digit,
Yeah.
and 1 digit is gonna be like just 2 or 3. Now we need these kind of numbers. That means for sure the first place cannot be 0. If I write 0, it's gonna be 2 digits number, right?
Mm-hmm.
So you have to make sure that we are not able to place 0 there. So how many options do we have? One, two, three, four, five. 5 ways. And how many ways do we have for the second place?
Oh, it's basically how many options.
Options, yeah.
For the second place, we have 6 options.
Yeah. If repetition is allowed, yes, 6.
Oh, well, then we have 5. It's not allowed. Right?
Right. So 5 options, 5 ways of filling that. The third position, 4. So you should be, you know, you should be clear about all these things. I mean, logic. So the third place or this position cannot be 0. So now we multiply them 5 times 5 times 4. So 20 times 4 is 80 ways.
Yeah.
So we have 80 numbers made out of those digits, and they're 3 digits. So we can make 83 digits number using this set.
Okay. That makes so much more sense.
Now we'll go over more questions probably in next session.
Okay.
And
No,
let's.
honestly, like, man, like, I didn't understand anything in class today.
No, that's good.
But
So
it's so easy.
yeah, it's easy. You can watch my YouTube channel, London Math Solutions,
Is that
or
gonna be on YouTube?
yeah, I'll put on my site www.londonmathsolutions.ca,
Okay.
so you can watch it there.